We're going to cover section 7.3 today. We're going to cover secants. Our objective is to find the measure of an angle formed by two secants and to find the measure of lengths of segments formed by two secants. A secant is a line that intersects a circle in 2 points. Similar to a chord, except it keeps on going outside the circle. It's a line. A chord is a line segment. A secant is a line. We're going to take a look at this situation here. We're going to find the measure of the angle AEC formed by the two secants intersecting. All right, so we're going to find the measure of this angle. To do that, I know that arc AC is equal to 80 degrees. So from that, I know that angle ADC is equal to 1/2 of 80 degrees, which is equal to 40 degrees. Right? So this is 40 degrees. Then we got arc BD. Okay. Arc BD is equal to 20 degrees. So from that, I know angle DAB is equal to 1/2 of 20 degrees, which is equal to 10 degrees. So that's 10 degrees. Can I now find angle AED, Brent? Yeah, we can use the exterior angle theorem. We can say that angle ADC which is the exterior angle, angle ADC, is equal to angle DAB plus angle AEC. Right? That's the exterior angle theorem. This angle is equal to the sum of this angle and that angle. And the AEC is the unknown, so we'll solve for AEC. Angle AEC is equal to angle ADC minus angle DAB. So that's equal to 40 minus 10, which is equal to 30 degrees. All right, any questions? Okay, so we have just done a numeric proof. Make sure everybody gets this written down. Everybody have this? You might need more time. We have just done a numeric proof of this theorem. If two secants intersect outside a circle, the measure of the acute angle formed is equal to half the difference of the measures of the intercepted arcs. So it's saying that angle AEC is equal to half of AC minus BD, right? We're also going to prove this formally. Okay, without numbers, we'll prove it. Okay. So given the secants AB and CD intersecting outside a circle at a point E, we need to find prove that AEC equals 1/2 of AC minus BD. So we draw in the line AD like we had in the original example. And we can say ADC equals half of AC. How come I can say that? What's the reason that I know ADC equals half of AC? Bryant? Right, that's the inscribed angle theorem. How about DAB equaling half of BD? Brittany, why is that? That's the inscribed angle theorem. Step 3. What do I know by the exterior angle theorem? Luke, what do I know by the exterior angle theorem?
Exterior angle equals the angle 1 and angle 2.
Okay, well, give letters to it in this picture.
Okay. Angle AEC, angle ADC equals angle DAB plus angle AEC.
Yeah, angle ADC equals angle DAB plus angle AEC. Very good. Okay, now how do I get to the next step where I solve for AEC? Well, how do I do that? What am I doing to the equation in step 3? What algebraic step am I taking there to go from 3 to 4? How do we get rid of the DAB that's with the AEC? How do I get rid of that and get it to the other side? What am I doing? Yeah, it's subtraction property of equality. All right. And then the last step, by substituting and simplifying the steps above, I can say angle AEC is equal to 1/2 of arc AC minus 1/2 of arc BD, which is equal to 1/2 of AC minus BD. Questions? No questions, okay? The other theorem that deals with secants is this theorem. If two secants intersect outside, so this deals with the segment lengths. Just like with chords, we had one that dealt with segment lengths. Now we got one with secants. It says two secants intersect outside a circle, then the product of the lengths of the two segments formed on one secant is equal to the product of the lengths of the corresponding segments of the other secant. Now you have to be careful because you're taking AE, that whole line, times BE. Okay? The mistake people make is they'll take BE times AB. It's not the part times the part. It's the whole AE times the part that sticks outside the circle. So it's AE times BE will equal to CE times DE. Right? And so that's how that theorem works. Okay? We'll do an example here in a second. So find the measures of CAE and AD. All right? So we've got angle CAE is going to equal to what? In terms of numbers, what would it equal to? What do we have to find first before we can do this formula? What do I have to find first, Bryant? How would you find that? Yeah, add the other arcs up, subtract them through 360. So what's BD going to be? Michelle? What? 40. You're right. That's 40. BD is 40. All right. So what do I plug into my formula? What are the numbers going to be, Braden? Not sure? Anybody? It's our formula we're going to use, okay? Christopher?
Angle CAE equals 1/2 90 minus 40.
Right. Angle CAE equals 1/2 90 minus 40, which is equal to 25 degrees. So CAE is 25 degrees. All right, now we're going to apply the second one we talked about. Let me clear this off. Now we'll do the one with the segments. So in terms of letters, what is my equality going to be? In terms of letters, what would it be? If we're doing the segments. Okay, Bryant? Say again?
AE times AD.
Okay, good. AE, the whole, he says, so it's the AE times AD. So AE times AD is equal to what, Bryant? AC times AB. Right. And the unknown is AD. We'll call that X. So we would have, so AE is 19 plus X, or X plus 19. AD is X. That equals to, AC is 21 times AB is 5. Right? So then we multiply everything out, we get X squared plus 19x equals 105. So then we have x squared plus 19x minus 105 equals 0. And now we can't factor that, so we have to use quadratic formula. So that's going to be x equals negative b, which is negative 19, plus or minus the square root of 19 squared minus 4 times 1 times negative 105, all divided by 2. So that equals to negative 19 plus or minus square root of 781, all divided by 2, which is equal to approximately 4.47 inches. So AD is 4.47. All right, any questions there on the notes? No questions on the notes.